the permission, you can record.
谢谢老师。
This class I introduced the stable motor control. Stable motor. This is drive circuits for bipolar. And this is controller gives the control signal. The CCWR and the CWR counterclockwise or counterclockwise signal. And this is a pulse generator. Pulse generator and is pulse generator generates the pulse. Give the pulse to the step motor. Step motor for every motor coils. Every motor coils. Before the pulse go to went to the motor coils, the pulse needs amplified. Is the controller just give the direction signal. Direction signal. Direction. This is direction signal. And the pulse sequence generator generates the pulse. This is the pulse. And the pulse pulses are amplified by this driver amplified, and they given to the motor coil. Given to the motor coil. This is a drive circuit for unipole. Someone give me a message. Who cannot see the files I shared in the meeting. I suggest you download the latest version for the net meeting. Net meeting client. Download the latest net meeting client.
Which one?
You can download from your app store. App store.
App Store.
Yeah, you download from the App Store, or just use the net meeting update. Net meeting update.
It's an app or something else, like any website or something else.
Let's continue. Continue. This is the drive circuits for unipolar. This is a direction signal. Direction signal. This is a pulse. Pulse generator. Pulse generator. Use the decoder as the pulse generator. This is a driver circuit. This is driver circuit. This is a motor coil. This is a motor coil. Next, I introduce the interface. Interfacing. Interfacing step motor with the 8051 microcontroller. Microcontroller. We'll see how to connect step motor with the Intel 8051 microcontroller. Before discussing the interfacing technology, we will see the what's the step motor and then how they work. Step motor are used to translate electrical pulses into mechanical movement. In some disk drivers, dot matrix printers, dot matrix printers, and some other different places, the step motor are used. The main advantage of using the step motor is position control. Position control. Step motor generally have a permanent magnetic shaft. Permanent magnetic shaft. And it is surrounded by stators. This is stators. This is rods. Rods is a permanent magnet shaft. Normal motor shaft can move freely, but the step motor shafts move in fixed, repeatable increment. Some parameters of step motor step angle. The step angle is the angle in which the rods move when one pulse is applied as an input of the stator. This parameter is used to determine the positioning of a step motor. Step per revolution. This is the number of step angle required for a complete revolution. So the formula is steps per revolution. Step per second. This parameter is used to measure a number of steps covered in each second. RPM. The RPM is the revolution per minute. It means it measures the frequency of rotation. By this parameter, we can measure the number of rotations in 1 minute. As we know, the step motor is driven by the pulse. So the frequency of pulse is which means the speed. And the number of pulses means displacement. The relation between RPM step per revolution and step per second is neg. using P port 0 of 8051 for connecting the step motor, use this component as a driver. It is basically a high voltage, high current Darlington transistor array. This is a driver IC. Driver IC. Each ULN2003 has 7 MPN Darlington pair. It can provide high voltage output with common cathode clamps dials for switching inductive node. The unipolar step motor works in 3 models. The model one is a wave drive model. In this model, one coil is energized at a time. One coil is energized at a pulse at a time. So all 4 coils are energized one after another. This mode produces a nice torque. Then 4 step drive model. The following table is showing the sequence of input states in different windings. This is a step motor has 4 windings. Winding A, B, C, D. When the step motor is driven in wave drive model, there is 4 steps in one revolution. Step one. The winding A is power on, and the A is power on. The other windings are power off. So power A, power B, power on C, power on D. Start another cycle. This model we call the wave drive model. 4 drive model. In this model, 2 coils are energized at the same time. This model produces more torque. Here, the power consumption is also high. The following table is showing the sequence of input states in different windings. In 4 drive model, every time 2 coils are energized. Step 1, A and B are energized. Step 2, B and C are energized. Step 3, C and D energized. Step 4, D and A are energized. So after 4 steps, start another cycle. The third model, half drive model. This is a full drive model. This is a wave drive model. Half drive model. In this model, 1 and 2 coils are energized alternately. At first, 1 coil is energized. Then 2 coils are energized. This is basically a combination of wave and full drive model are. It increases the angular rotation of the motor. The following steps are the following table is showing the sequence. For one revolution, there are 8 steps. Step 1, A is winding A is energized. Step 2, A and B. Step 3, only B. Step 4, B and C are energized. This is called half drive model. This is an example for the circuit to drive circuit this is driving the step motor. This is a driver IC. Driver IC. This is a motor.
Rashid, this
Yeah.
driver IC, how many motors can it take?
Sorry.
This driver IC, how many motors can you connect to it? Only one?
This IC?
The driver IC, the U2, how many motors can it take? Can you connect to it at a time?
This IC. I didn't put the data sheet here. And let's give you see the data sheet. Wait a minute. This is the data sheet for the driver AC. Driver AC. This is input pin 1, 2, 3, 8 7 input output 1, 2, 3 to 7 7 When we use this driver IC, we give the input signal to in 1, 2, 3. We can select some of in pins. Then this is output. Amplify the signal. Signals are amplified and output from the output pin. Out pin. This is the code for the example. You can exercise this practice. You can practice.
Can you show the code again? The code. Can you show the code again?
Yeah.
Okay. Yes, sir.
This is a simple code. I will give you the code. I will give you code.
Thank you.
Last class, I give you I give you a assignment. And this is another assignment. You finish this step motor control. Just finish this example. Finish this example. You can write the code by yourself, or you can reference this code and change it for yourself. Change it for yourself.
What's the deadline to submit for this?
Sorry.
What's the deadline to submit for this homework? He's
asking what's the deadline? Deadline for this. When should we submit this homework?
When to submit this assignment?
Yes, Lashi.
Yeah.
You can. I suggest you give me this assignment in 1 week. Okay.
In 1 week. That means next week.
Next week.
Okay, sure.
Okay.
Next week you give me the this assignment. I give you last class and this assignment together. Okay.
Together. Okay, Lashi.
Okay. This is another example. Another example. Step motor interfacing with 8051. This example uses a different driver IC. Driver IC. Use
1000.
This one. This one. And
that's
the slides. We use ULN 2003.
I have an offer for you. If you are going to be patient.
This example, we use L29 3D, L29 3D as the driver IC. This is components for the circuit components. This is a circuit. P2 P2 used as output port to the L2 LAN 3D LAN 3D to the driver IC here P0 used as input port P0 input port we got the button signal is connected to them so that we can manually start and stop the motor Step motor is giving input through out 1, 2, 3, 4 1, 2, 3, 4 of L2 LAN 3D L2 LAN 3D this is battery 12V battery gives a signal give input to the VS for the motor 5 battery for the driver IC working steps step motor interface with the 8051 microcontroller use all this model as we know the step motor has 3 working model 3 working models here we use 3 model when I push button 1 it works as wave driver only one electromagnet is energized at a single time and the encoding 1 pin is high at a time when I open the switch button, motor tends to stop and get stopped within a few seconds. This is wave drive step model. One pin, one lens is energized. When press button 2 it works as a full drive two electromagnets are energized at a single time and in coding 1 pin is high at two pin is high 2 pin is high. When I open a switch button, motor tends to stop and gets stopped within a few seconds. When I press button 3, it works as a half driver. 1 or 2 electromagnets are alternatively energized at a single time. Encoding. First pin is high, then first and second both get high. Second alone goes high. Second along with the third goes high. First pin high, first and the second pin high. The second pin high. Second and the third pin goes high. Goes high. As button 3 control of the half driver model. This is a code for this example. It's code for this example. For our for the step motor you need finish the two facing finish the two example finish the two example. One is driven by the L2 line D and another is driven by ULN 2003 2003 everyone and need we need to finish two example for the assignment so this assignment is for step motor
Actually, this is the question.
Sorry.
This is the question for the assignment.
Question.
You said we should. So if there's no question, we should just use this to interface the stepper motors. Okay.
Sorry. You can text me, okay?
Okay. Actually, you can go. I'll ask you later. You can continue. I'll ask you later.
I hope everyone can after you finish the example, you know how to drive the step motor next I introduce the brushes which one is the example for the step motor?
Yes, Lars.
The two example is for step motor. The two example two example are for step motor. We just use different drive IC. Just use the different drive IC for the step motor.
Okay.
Yeah. Brushless DC motor. Brushless DC motor. Brushless DC motor. Brushless motor called the BLDC. Use permanent magnet instead of coils in the armature or rod. And therefore do not need brushes. The field coils are switched on and switched off. The field coils are switched on, switched off in a rotating sequence. That pull the rods around. They have built-in sensors that direct when the individual field coils are to be switched on and off. They are available in a wide power range and they can operates at a very high speed, up to 30,000 RPM, 30,000 RPM. They are able to generate a high torque for a given size, DC brushless motor are the most widely used motor technically for several applications. This is a figure for the brushless DC motor. Brushless DC motor basically work like the step motor. We give the power to coin A. The rod is drawn by the magnet. Then after we switch on the coin C, the rod is drawn by the magnet, so the to here. Then we switched on this switched on this coin coins B, and the rod is drawn by the magnetic rod like along this direction, as a brushless DC motor, use the optical slotted coupler, control the circuit switched on and switched off, When the slot is goes through the coupler, the coil is switched on, So the three coils are switched on in tens, This is the structure for brushless DC motor. As I see, basically neither step motor, Brushless DC motor advantages reliable, high performance motor technology, long life, reliable, high performance, long life, virtually maintenance free, cooler running, no acoustic, Initial like the AC motor, the brushless DC motor, no brush, so virtually maintenance free, They run relatively smooth and quiet. They do not require mechanical brushes for commutation. Disadvantage, high price due to use of rare earth magnet material, because the magnetic material. They also require fairly complex and thus more expensive amplifiers. which means the brushless DC motor, the disadvantage is high price. High price. Next, give you an example for the servo motor. For the servo motor, the motor used as the servo motor. Servo motor. Servo motor have a built-in shaft encode. Shaft encode. Combine its motor with under the encoder. We use it. Use the motor as a shaft. As a servo motor, as a servo motor. The data sheet provides the required passes for specific speed and position. The supply give you the data sheet. You can use for reference the servo motor. Servo motor. Oh, sorry, I put the oh, okay, everyone, let's have a rest.
Okay, Lashi.
Okay, Lashi.
Okay. Hello. Hello.
Yes, 老师. Hello.
Hello, 老师。Hello, 老师。
Let's continue our class.
Yeah, 老师
Okay.
sure.
Okay, 老师。
It's a long break. Yeah.
Okay, let's continue.
Yeah, Laoshi, the break was really helpful.
Really helpful. Yeah, helpful.
For what?
Yes, Laoshi.
Yes, last year was good. We relaxed. Now we are back very fresh. It was good. It was good. Thank you, Lashi.
Thank you, Laoshi.
Okay. Let's continue on. Let's continue. Last class I introduced the DC motor. I put the wrong sequence about the step motor. Step motor. So I continue introduce the step motor for some conception. Some conception. Step motor. Step motor are basically DC brush motor. Basically DC brush motor, which means step motor is a DC motor. DC motor. However, they do not require an encoder for position feedback. For position feedback. The DC motor used as a servo motor it need the encoder. But the step motor they basically they do not require encoder. They rotate in fixed steps as related to number of degree. Step motor produce a high torque for given size and weight. However, the available torque from step motor drops dramatically with higher speed. The maximum speed around 5,000 RPM is every no torque. The power range of step motors is up to several hundreds of watts, but hardly above that number. Several hundred. The major drawback of a step motor is the noise and the vibration. They produced especially vibration can affect the lifetime of a mechanical system significantly. And this is the advantage for the step motor, noise and vibration. Here is a two-phase step motor bipolar. There is coils, two coils. Two coils. There is two coils. This is a pile of coils. Four-phase step motor unipolar. There is four coils. Coils 1, 2, 3, 4. Coils 1, 2, 3, 4. This is a three-phase step motor bipolar. Unipolar only one coil for one pole, one phase for one phase. The bipolar step motor two coils for one phase. Two coils for one phase. This is a model of operation. The step motor. The step motor. Running operation. Running operation. Single step. Snow model. Snow model. Single step. The step. So the coils switch on. Then after a while switch another the step the curves next step if we use the snow model the position and the time the curves almost linear almost linear this is a data sheet for the step motor. When we select the step motor, we need the data sheet. We need the data sheet. This is an example for the hard drive application. Hard drive application. Computer gives a signal. Give a signal. The output port. Gives interface for the driver IC. Driver IC. The driver IC receives the step pulse signal and direction signal, and amplifies the signal and gives a pulse to the step motor. Step motor drive this need screw and move the head read head. This is the application for hard drive. Step motor control. The control circuit I have already introduced in the last class. I don't introduce repeatedly. This is drive. Just remember your assignment. Just remember your assignment. There's another example. Five phase. 1, 2, 3, 4. 4 phase. The 4 phase step motor. This is example. You can do your assignment just like this figure. This figure. Next, I introduce the AC motor control circuit. AC motor control circuit. AC motor control. Once the motor is running, its speed will be determined by the frequency, which is why the AC motor usually sort of as a constant speed motor. Its speed determined by the frequency. So when the power supply frequency is fixed, so we use the AC motor as a constant speed motor. AC motor are essentially limited to running at a speed determined by the frequency. If you want to fully control the speed of an AC motor, if you must be able to change the frequency. Here I introduce the VVF. Variable voltage, variable frequency, variable. If we want to control the speed, we could either control the frequency of power supply. So we use a VVF. Use VVF. VVF speed control method is widely used method for induction motor. As we know, that the synchronous speed of a machine is given as this F is the frequency, P is the number of torque of motor. Thus, if we can change the frequency, then it's possible to change the speed of induction motor. Now, frequency of power supply can easily be varied using power electronic. Like invert. The inverter convert DC power into AC power. And feed to induction motor. An inverter output may be either constant voltage, variable frequency, or variable voltage, variable frequency. Here, which one to select, to choose? Which one to choose? Which one? Constant voltage, variable frequency, or variable voltage, variable frequency, which means we output the power, the voltage, if voltage change, Suppose inverter output is constant voltage but variable frequency. We can write V is equal to constant, but F is equal to variable. Relation between V and the frequency is well known, can be written as this equation. The V voltage is this is relationship. Where N is the number of turns per phase, 10 pins. And phi is the resultant, L gap flux, Suppose we want to reduce the speed of induction motor. For obviously we will have to reduce the frequency F while keeping V constant as per 1. But from 2 we can get this equation. if the F is change, is F change, especially F is smaller, which means the phi L gap flux, L gap flux is bigger, which means this L gap flux maybe exceeded the L gap flux will increase, which maybe cause machine core saturate, which is not desirable, Thus, the concept of speed control with constant voltage variable frequency cannot be adopted. From 3, it is possible to achieve constant fluxes phi by maintaining V reaching F constant. This allows us to change voltage and frequency simultaneously to have speed control while maintaining constant L gap fluxes. This is basically concept behind VVF speed control of induction motor. In the VVF speed control, the reaching of VF keep constant. In VVF speed control, motors this supply as well as frequency is varied, such as that reaching VF is constant. Torque in VVF speed control as discussed, frequency is varied. Therefore, it is quite important to have a look at the maximum torque at variable frequency. Reference the equivalent circuit of induction motor. As we know, that torque in an induction motor is given as this equation. Torque. To get the maximum torque, we need to differentiate the above equation WRT with respect to S, and equates it to zero. This will give us the value of the slips at which torque is the maximum as below. When the S is equal to this, the torque is maximum torque. This value. Thus, maximum torque is independent of frequency. But the speed at which maximum torque will appear well studied as per 4 As we increase the frequency f omega the angular speed also increase. This in turn will reduce s as per 4 omega is big, the S is smaller. Thus, increase the frequency will increase the speed of induction motor, and the speed at which maximum torque appears will have the same maximum torque. The same maximum torque. This is a figure about the variable speed control. Variable WWF, variable speed control. This is the power supply frequency. Change the AC to DC with the converter to any DC. Then convert the DC to AC converter to any frequency. So give the frequency power to the AC motor. We can control the AC motor speed. AC motor speed. Here is the power supply. Here is the AC to DC with the rectifier. Here is the DC to AC. DC to AC. Pursued three-phase generator. This is a variable speed control. Pursued three-phase come from here. When we use the PWM, in the variable speed control, the signal come from the three-phase generator. Three-phase generator, just like this. AC motor speed control circuit use 89 C51 CD1. Here is a simple circuit AC motor speed controller circuit using microcontroller, which is used to control the speed of AC motor using microcontroller. The circuit uses the principle of change file engine of tri-X in order to control the speed of motor. Here in this project, we had used various switch in order to control the speed, whereas LED bar graph is used to indicate the speed of motor. The circuit diagram of signal phase AC motor is divided into three main sections. One, first, fire edge control circuit. Second, zero corrosion detector circuit. Three, speed indicating circuit. Firing angle control circuit. This firing angle control section shown in the figure 1. This is figure. This section consists of a microcontroller and optic coupler. The optic coupler is used to trigger triac. This is the optic coupler. Whereas a microcontroller is used to control the angle and the indicating circuit. The output of zero crossing detector is given to external interrupt on PIN 12. PIN 12. You can see this one. Maybe this figure is small. We cannot see it clearly. Pin 13 line is connected to the input of optic coupler, whereas the output is connected to the gate of triangle. Here. The switch SW123 connect PIN 1, 2, 3 respectively, where diodes D9, 8, and 7 are connected as shown in figure 1. This is a switch connected to the pin of microcontroller. Where the function of each switch is shown in table. This is the function for each switch. For power on, reset capacitor C5 connected in serial with the resistor as shown in circuit diagram. Reset here reset here. This is a full diagram for this example. This is some special about this diagram is the max 232 max 232 This is a serial communication IC serial communication IC convert the TTL to the serial communication serial communication level. This is the IC and integrated circuits designed by indicated products act as a voltage logical converter used to convert the TTL logical to this level for the serials port serials port. Next, zero corrosion detect. Zero corrosion detect. Zero corrosion detect circuit is shown in Figure 2. In Figure 2. Here. It consists of a voltage regulation section and zero corrosion section. The input of 220 V AC is given to primary windings of transformer XR, which is stepped down to 9 V AC and changed to pulsating DC using bridge rectifier circuit. Bridge rectifier circuit. One output of rectifier is given to voltage regular through dials D6. The output of regular AC is pure 5V DC. 5V DC, which given to the collector of transistor T1 and T2 as a bias voltage. This is a voltage regular 8. Regular 8. This here is a 220 V. Here is 9 V. Is 9 V. This rectify. This bridge rectify converts the 9 V 9 V AC to 9 5 to the 5 5V DC 5V DC. This 9V AC to the 9V DC. After the voltage going to the voltage regular 8, come out the voltage come out is 5. Here is 5. Here is 5. Here is 9, 9, but the 9 is not stable. The 9 is stable. The 5 voltage come from the voltage regular is pure 5 voltage. Pure 5 voltage. The pure 5 voltage are given to the connector of transistor T1 and T2. Transistor T1 T1 and T2 and T2 this voltage given to the T1. Sorry. Sorry. This is not right. The voltage given to the T2. Just give the T2. And give the here. 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 This is given to the connector, the connector pin, the connector pin. Here. Here. For the transistor, here is the connector pin. This is the base pin. This is the emitter pin. This is emitter pin. 3 pin for transistor. Transistor. Similar, another output of rectify through dies D5 is given to the base, given the base of transistor T1 through voltage divided circuit, voltage divided circuit comprised of resistor R2 and R3. D5 D5 T1 D5 here is D5 does D5 give the two here R2 and R2 and 3 R2 and 3 here the base this is the base of T1 of T1 The output of transistor T1 is given to the base of T2 give the T1 the output T1 give to the base of T2 and T2 base T1 here this output of T2 is given to pin 12 INT0 of IC2 here next indicator circuit indicator circuit this indicator circuit is showing in figure in figure 3 in figure 3 this circuit consists of bar graph display and the current limiter resistor R7 and it is used to indicate that the condition of motor as well as the speed This indicator circuit consists of LED LED are connected to the pin number 16 of IC is to indicate zero corrosion detect circuit status. This blinking LED represents zero corrosion detect circuit is working okay. The LED are connected to pin 13 is used to indicate the motor power on. When the LED is on, it means the motor power is enabled. If LED is off, it means power is disabled. This is indicates circuit consists of LED. This circuit, this circuit is I just give you this circuit, but I didn't prepare for the Protos simulation. If anyone is interested, you can use Pro Tools software to simulate this circuit and give you your opinion about this circuit about this circuit
I hope you send it to us. We take a picture from here. We can't.
This is a component for this component for the this circuit component resist capacitor and the IC transistor diode. This example is for is for the speed control of AC motor speed control of AC motor. Next, I introduce the variable frequency drive. Variable frequency drive. We will learn about the electric motor. What is a variable frequency drive? Working of adjust the frequency drive system and the benefits of VFD. As I introduced in the last class, variable frequency drive, which means variable frequency, variable voltage. We just give some conception about the VFD. Basically, all AC induction motor are constant and the machine speed machine when run through the main power supply. In fact, the difference in speed from load to full load is at the maximum of 5%. It is often desirable to operate the motor at a variable speed for variable purposes like saving energy, improving efficiency, controlling the torque of process. Automation of industrial process has led to variable speed drive of AC motor. Variable frequency drive is a tech often used to achieve the adjustable speed drive of AC motor to control its speed as well as torque. Needed for variable speed drive. Before going to the details of variable frequency drive system, let us take a look at the need for variable speed operation of an electrical motor. As mentioned earlier, all AC motors are constant speed machine, and the applications of such fixed speed motor are numerous, like conveyors, dampers, valves, etc. For example, but the lead for speed and torque control of electric motor is also essential. Consider the simple example of an electrical car. Today, many car manufacturers are making all electrical vehicles that run on batteries and electrical motor. After the success of Tesla, it is obvious that the speed of the car must be constantly controlled by the driver. Depending on the traffic condition, speed limits, highway etc. to avoid collision, avoid the collision. This means that the car must be start, accelerate, de-accelerate, decelerate, and stop whenever required, depending how much the accelerate pedal is pressed. The speed of the car varies. The integral part of our life is essential a variable speed control system. In the above example, the need for controlling the speed and torque of motor are very essential. Another important need for variable speed drive like VFDs is to save substantial amount of energy, as electrical motor are one of the major energy consumers in industries, and having efficient process is very important. Here we just talking about the three phase AC motor, three-phase AC motor. Types of variable speed drive. Variable speed drive can be achieved in many ways. The following is a list of the three major variable speed drive categories and some of the methods used in each categories. Mechanical variable speed drive, hydraulic variable speed drive, electromagnetic electro variable speed drive, etc. This is the mechanical. It's hydraulic. And this is a electromagnetic. This is a electrical variable speed drive. Motors. Some of the components using is a motor. Okay, everyone, let's have a break.
Right, 老师。
OK，老师 OK。
休息一会儿。 Hello.
老师
Hello，老师。
Hello，老师。
Let's continue our class.
Yeah, sure.
OK，老师。
OK，OK。
I introduce the variable frequency drive. Variable frequency drive. The variable frequency drive, or simply VFD, is one of the commonly used technique for controlling the speed of an electrical motor. In this technique, power electrical device are used to vary the frequency of the input power to electrical motor by a technique called pulse wise modulation, PWM, and thereby controlling the speed of the motor, VFD systems using PWM is capable of adjusting both the speed and the torque of an electrical motor, and therefore provide a continuous range of precise speed control. A variable frequency drive system is known as an adjustable frequency drive or variable speed drive or variable voltage variable frequency drive. This is a simple device that controls the voltage and the frequency of the input power of a motor, and therefore controls speed of the motor as well as the system being driven by the motor. The main components of VFDs are the following image shows a simple overview of VFD systems. It consists of three main components: rectifier circuit, DC circuit unit, and PWM inverse circuit, PWM circuit invert. This is a AC line. After through the rectifier, the AC becomes a DC. We keep become DC. So this is here is a DC circuit. DC circuit. DC circuit inverted to AC circuit. AC circuit. And the inverter is controlled by the voltage and the frequency control. And we will see more about this component in the working, but I will give a brief note on each. Rectifier circuit is used to convert the input AC power to immediate DC power. DC circuit unit, DC pulse.
老师
Yeah.
老师 do you have any circuit to show us like individually? 老师
Yeah.
Yeah, I mean, do you have any circuit like real life circuit to show us? Not this diagram.
Real circuit.
Yeah.
This is almost the real circuit. This is dials.
Yeah, diode. Yeah, that's true.
Yes, diodes. Yes, diodes with rectify the AC to the DC.
Mhm.
Here is the DC circuit. Basically, we use the capacitor. This is a capacitor. Capacitor, but
Capacitor.
more than capacitor. Maybe there's other component. There's other component. This diagram just show us the principle. Principle. Maybe in the actually circuit, there is more than the components. More than the components.
Yeah, that's true. But it will be more effective or attractive if we can see the real circuit, you know.
No, we
Yeah.
we don't have any real circuits.
Oh,
And
okay.
the manufacturer for this will never give you the real circuit. We just
Oh.
know the principle and then know the main component. But we don't have any real circuits.
Oh, all right.
You can use the Pro Tools to test this principle circuit. You can test the circuit by with the Pro Tools software. Maybe you will see some thing happen. Something happen.
Yeah, yeah, good.
This is DC motor. DC motor, DC circuit. DC circuit use the capacitor to filter the noise. Filter the noise. PWM inward circuit. PWM inward circuit. This is a inward circuit. Inward circuit. Use the transistor. Use the transistor. This is a transistor. And the diodes. Transistor and the diodes control the circuit and invert the DC. Invert the DC to the AC. Invert the DC to the AC. The inverter unit converts the immediately DC power into sinusoidal three-phase AC power using PWM technique. PWM technique. Working of variable frequency drive systems. Even though frequency controlled method of changing the speed of an AC motor is a well-known technique, it is only recently that this technique has gained widespread use and popularity. In spite of the high cost, complexity, and maintenance of DC motor, they are frequently used in almost all variable speed drive applications. But the development in semiconductors, especially in power electronics, and the low cost of squirrel cage AC inductor motor has attracted AC drive. The high cost complexity is these are the disadvantage of the VFD. Using various technical like VFD, you can not only control the speed of an AC motor, but also its torque. This fundamental principle in AC variable speed drive is very simple. We can understand it by starting with the AC motor itself. As I introduced before, the speed is calculated by this equation. The speed change and the frequency change the speed change. The synchronous speed of the motor, i.e., the speed at which stator's magnetic field rotor is dependent on the number of poles in the stators as well as the frequency of supply current. PWM variable frequency drive. When the AC inductor motor is operated at a constant frequency power source from usually 50 Hz or 60 Hz, the speed of the motor is fixed. A variable frequency drive system, as the name suggests, controls the speed of an AC induction motor by varying the frequency of the power supply. A VFD must also regulate the output voltage according to the frequency, so that the output voltage to frequency is more or less constant, which is the basic characteristics of an AC motor to produce a constant torque. This is just a simple diagram for the principle. So the first step of VFD is to convert the three-phase AC power to DC power using simply dial rectified circuit. The rectified DC power contains voltage ripples, which are smoothed using filter capacitor. Use filtering capacitor before being fed to the inverter. This section of the VFD is known as DC link circuit. The DC voltage must then be converted back to AC with variable voltage and frequency. This is done using a power electrical device like integrated gates by polar transistor or simply IGBT, power transistors, using pulse-wise modulation. Output voltage is turned on and off at a high frequency, and the duration of on-off time, i.e., the pulse-wise, is controlled using a control unit to approximate a sinusoid known as quasar sinusoid wave quasar sinusoid wave this is a quasar sinusoid wave The entire process usually monitored by a control unit consisting of an MCU microcontroller or microprocessor. The job of a microcontroller is to monitor the incoming supply voltage, set the speed of the motor, monitor DC link voltage, check that the output current and the voltage within the reasonable limit. Benefits of VFD are. The following are the benefits of using VFD in high voltage alternating current systems. Other applications will also have a similar set of benefits. A typical HVAC system consists of fans, pumps, compressors, eye handlers, and chillers. All the motor-related devices can have the following benefits when used with variable speed drive systems. Simply installation and maintenance, no motor starting current, energy saving, reduced mechanical and thermal stress on motors and belts during start, high power factor and no kVA, This is some benefits when we use the VFD. This is a VFD circuit. Maybe you can use the Pro Tools to test this circuit. Next, I give you a summary about the motor. The transistor is a current amplifier, and therefore the node current will be a multiplier of input base current transistor amplifier is an amplifier. The BJT bipolar junction transistor is a three-terminal solid-state device that controls the flow of current through a node. The FET performs the same job as the BJT. The main difference being that the node current is a function of the input gate voltage. The SCR is a three-terminal solid-state device capable of switching a very large DC current. Very large DC current. There are two ways to control the speed of a DC motor. Analog drive using linear amplifier to provide the varying DC voltage to the motor. PWM provides the motor with constant voltage pulses of varying wise, two ways. AC motor are essentially limited to running at a speed determined by the line frequency. Therefore, in order to control the speed of AC motor, SCRs and transistors are used to change the frequency. This is a method how to control the speed of DC and the AC motor and the AC motor. Here is the drive component, driving a component, drive component. We can use it to amplify, use it as an interface of no power and high power, no power and high power. Okay, this is the end for the drive circuits. This is the end for the drive circuit. Okay, next, I introduce the control system, control systems. As I introduced before, and we know the microcontroller is used in the control systems. So we need programming the systems for the control. Control systems is at the heart of mechanical systems, and its selection is inarguable the most critical decision in the design process. The controller selection involves two interdependent parts: hardware and software. Hardware and software. Software control method. Hardware the controller, physical controller. Physical controller. Basic control steps. Basic control steps. The control is open and closed loop control, process and motion control, transistor and steady state specification. Open loop. Open loop set the point, give the controller gives it to the actuator, actuator give to the process, and the process give to the controlled variable. No signal back to the controller. No signal back to the controller. We call the open loop controller. Open loop controller. closed loop controller. Closed loop controller. Set the point after through go through a comparator. The signal go to a controller. Controller give to the give it to actuate. Actuate give it to precise. The precise gives it to control variable. Control variable. At the end of the control, the sensor sense the sensor the status and the feedback to comparator. Comparator. After the comparator, the signal goes to controller. Controller. This is called the closed loop control. Closed loop control. Which means if there is there is a sensor in the loop, the sensor in the loop, maybe we call it closed loop control. Closed loop control. Control system classification. Control system classification. Control systems are classified by application. Press control, motion control. Press control, motion control. Process control usually refer to industrial process being electrically controlled for the purpose of maintaining a uniform correct output. Process control usually refer in the industrial process. Being electrically controlled for the purpose of maintaining uniform correct output. And press control and industrial process. Industrial process. Motion control. Motion control. Motion control refers to a system wherein things move. Where the things move. A servo mechanism is a feedback control system that provides remote control motion of some object, such as a robot arm or radar antenna. Radar antenna. Radar antenna. Motion control control things move. Moving. Control the moving. Control the moving. This is a diagram for the press control. Process control. Process control. Controller. Controller actuates such as heating elements. Process. Such as oven. The controlled variable is the temperature. Controlled variable is the temperature. The temperature is feedback to the controller. Feedback to the controller. The process variable. Process variable. The temperature is a feedback to the controller. Controller. Process process control example. Process control example. This is a mixture systems. Mixture the blue and the yellow two together. So the system just control the flow, control the flow for the different the canal. So according the flow and control the valve, control the valves. And the control systems give the correct sequence for the valve under the correct flow speed and get the correct green correct green. Motion control motion control such the controller gives the signal to the active edge, give the active edge. Here gives the working elements. This working elements. This is a active edge. Motor. The motor drives the controlled object. Drives the controlled object. So we can get the controlled status for the controlled variable. After the controlled variable is the feedback. To the controller. The systems become closed loop. Control systems. This is motion control example. CNC machine and the robots manipulator. We need control the speed and the position of movement. Speed and the position of movement here and here. We need to control the motion. Speed and the position.
Laushi, maybe can we finish it for today? It's too long for today. We need to learn these chapters.
You can speak again.
Laushi, could you finish it today? Because it's too long for today, and there are too many topics to learn. So maybe you finish it for today now.
Finish it 2 days.
Laushi, can you finish it now?
You want to finish the class?
Yeah, if you finish the class, then I think it will be better because it's too long. And today we have learned a lot. It's enough. Today, I
Maybe
think it's
after
enough.
10 minutes. Maybe after 5 or 10 minutes.
Okay. Maybe I give you a note. Give you a note. I can finish today's class. But I hope you can remember the assignment. Okay.
Yes, Laushi.
Laushi, can you give us the PPT? Or you already gave us the PPT?
I will share the PPT, the example I give you in the net meeting chat.
Okay. We are waiting.
Okay.
Okay.
Lao
We are waiting
Shi,
for you to share.
PPT on meeting chat, Laushi, send the PPT on WeChat.
I said I give you the PPT in the net meeting chat. If they don't come to the net meeting, they don't have the PPT. I don't share the PPT in the WeChat. Okay.
Okay, Lao
Share in
Shi.
the chat. Share.
Sorry.
Okay, Lao
Sorry.
Shi.
Okay.
Laushi,
So much for today. So much for today.
Laushi,
Yeah.
Please share the PPT. You didn't share.
next class you will continue from this part, right?
Next class.
You will continue from the part that you started right now.
Yeah.
Okay.
Please share the PPT. We are waiting.
Okay. Today's class is over.
Extra slow.
You are dismissed.
PPT.
Don't exit from the net meeting. I will share the PPT in the net meeting. Okay.
Okay, Ola.